Okay, so today we're going to be talking about building secure Java images with Chainguard Images. My name is Jason Van Zale. I've been around in the Java and Maven community for quite a while, currently living in Canada, and I help out at Chainguard in the Java program generally, and helping with any Java, Maven, and build systems in general in the Java ecosystem. So today we're going to talk about CVEs and security and how they relate to Chainguard Images. I'll probably have a short discussion on the Java program here at Chainguard, how it works, what we're striving towards, what is currently in place. We'll do a little fairly high-level demo. People who are familiar with Docker or Jib, we'll go through 4 build examples, again, very high level, building a simple Spring Boot application, running it, and then demonstrating what the differences are between what you would find in the normal Maven and JRE images and what you would find in the Chainguard JRE and Maven images. Anyone feel free to ask questions throughout. I'll try and answer them at a natural break, or Kirby will try and raise my attention to try and answer them. If you want to follow along, some of the tools that you will need are listed there. And the source code for this demo can be found. Let me just jump ahead here so people can grab it if they want. If people can see that there, sorry for not putting it earlier on, but if you want to follow along and grab the source code for the demo that I'm going to do, you can grab it there, and I will actually paste it in the chat. Just 1 second. You don't have to, but if you want to. There is the Git repository for the demos that we'll be doing. All right, so Chainguard as a company is trying to improve security by building most of the popular open source packages that you're familiar with from source on a regular basis, and generally on a daily basis. Most people who have been using open source for a number of years are familiar that the source code that you're writing in comparison to the source code that you're using from the outside world is extremely small. Most of your dependencies are coming from open source projects, Jackson, Spring Boot, Logback, Log4j, many open source Java projects that many companies rely on. Chainguard is trying to build all of those dependencies from source. Chainguard started out very much in the infrastructure space, building Docker images for lots of infrastructure packages. We're slowly moving up and trying to build other things that are used by the system, and Java is one of those things that we're trying to improve support for. On a daily basis, we are looking at upstream projects, patching them where necessary. Of course, our philosophy is not to hold on to any of those patches. We submit them where we can. We absorb the upstream changes as fast as we can. We build them very rapidly. Our SLAs are very short, criticals within 7 days, anything else within 14 days. And this is a constant cycle of fixing things, absorbing the changes, building them, publishing them, remediating these things as fast as possible. And generally what you will find on rare occasions, there might be a couple, but on any given day where you go to look at a Chainguard image, you will generally find that we have close to 0 CVEs, if not 0 CVEs on that day. We're building in a number of ecosystems, a number of different infrastructure products, anything you can think of in terms of a language runtime, Python, Ruby, Java, Go, Rust, These are all things we build on a daily basis and remediate on a daily basis. Just looking at some of the images we build, sometimes these fluctuate. Sometimes the open source projects are doing a little better. But most of the time, Chainguard is at 0 or close to 0, and the open source projects, just by virtue of the amount of work it takes, the diligence it requires to look at it on a daily basis, Chainguard Images have very low or no CVs. So as this relates to Java, I'll talk a little bit about the background of the Java program here at Chainguard. The first thing that we've done historically is try and bootstrap from as far back as possible as we can. This required quite a bit of work. We actually took GCC version 6, or branch of version 6. There was a lot of patches that we had to make in order for us to use GCC in a mode with Java 1.5 in order to build Java 1.7. From Java 1.7, we went through the entire chain building 1.7 to build 1.8, 1.8 to build Java 9, 9 to 10. You get the pattern, all the way up to the latest version that we have, which is 24 early access. So just understanding all the tools that were used to build it, that this was all built in a hardened environment. Our environments where we are building things are super locked down, very hardened environments. It's not only Java that we're rebuilding, but we're also rebuilding all of the packages that are required on the container to run and support running Java on a given system. So we're rebuilding those packages all the way down to the ground level. Compiler flags for like memory safety and hardening all the way down. So it's a very, as much as we possibly can with all the safeguards that we can, trying to build this in a super safe environment with as much security provisioning as possible. We have been signatories for participants in the TCK, the Java Compatibility Kit, for quite some time. So whenever we build and release a new version of a JRE and JDK, we are running the TCK on that and ensuring that it is compatible with any of the other OpenJDK based JREs and JDKs that are being released. Recently, we have started a performance program. So running the TCK is no indication of the performance that the build, what you've built. But we have started a program and have full-time people working on creating performance programs to make sure that any of the changes that we possibly may be making to the OpenJDK sources have not impacted performance in any way, shape, or form. One of the other variants of our JDKs and JREs that have become incredibly popular are the FIPS variants that we have. So the Federal Information Processing Standard, limiting bad cryptographic standards, making sure those are disabled, enabling more secure forms of algorithms. That is something that we are using, that customers are asking for. And we use that as the basis for FIPS versions of many of the images we provide. So Elasticsearch-based FIPS images, or Spark, or Druid, or many of the other forms of the Java-based application images that we have. Recently, we have also, our base JDK and JRE that we provide are based on OpenJDK sources, just like many of the other sources. But we are also building versions of Tamarin and the Corretto sources as well, based on customer feedback and requests. So we have our own OpenJDK that comes from the standard OpenJDK sources, versions of Tamarin and versions of Corretto, and that footprint may expand based on customer requests over time. All right, so if anybody wants to participate, if you've checked out the sources, these are some images that you can pull from Chainguard. They're relatively small compared to many of the other images you may pull. But if you want to get started to try and pull these down, feel free to do so. All right, so the practical demo that we're going to go through has 4 stages. We're going to do a simple Spring Boot application built with the Maven image. So that is probably going to be quite large. We will then try and compare what the Chainguard Maven image produces for you, and then switch to a multi-stage build using the standard Maven image and a multi-stage build using the Chainguard images. So I'm going to stop sharing the slides and share my terminal. Just 1 second. There we go, and anyone will notice that I'm quite an elderly Java person, and that is Midnight Commander, which of course was written in the 80s, probably earlier. So I am going to start with the first Docker file. So if we take a look at that, it is, and I've tried to lock everything down for today so that if someone tries to reproduce this, these are the Maven latest images and the Chainguard latest images, but I've locked them down as of today so that the demos are reproducible if you want to try and look at them in the future. So this is going to be a very simple Spring Boot application that we build with Maven in the same image. And if I run this Docker file, I'm just going to build it. I've pre-built it. If you're running it locally, it may take a while to actually download and execute everything. But this is our Spring Boot application built with Maven. If we take a look at the size of this image, so I have 2 tools here. I'm going to try and run this with Docker Scout. And we'll see what Docker Scout has to say. So the Maven image is actually in pretty good shape. The last time we did this demo, it had a few more CVEs, but we've got 13 CVEs in total for this application that we've written with using the standard Maven image. If we use the, now we're going to switch over and use the Chainguard Maven image. I'm just going to check the Q&A here. No questions yet. That's good. So this is now the Chainguard Maven image, which is based on top of the Chainguard JDK, which is based on all of the packages that we've rebuilt from the ground up. So let's run this build. Okay, so again, relatively straightforward. Again, let's take a look at the output of let's grab the image that we just built and take a look at it with Docker Scout. And we'll see, and this is fairly par for the course, is that the Maven image that we've used from Chainguard has 0 CVEs. All right, so in more common practices, it's generally not advisable to have the build tool be in the image that you are going to be building. So let's just quickly take a look at the size of those as well. So Docker, so the 2 images that we've built so far are an application image using the standard Maven image and one building. So you'll see there that the first one that we built, I've done the whole demo, so they're all there, but the Maven image is 655 megabytes. And the image that we've built with Chainguard, it's Maven image, is 392. So again, one of the standard things we're trying to do is reduce the surface area. So on the standard images that we build, there are no shells, there are no extraneous tools. There's generally less software on those images, and they have less CVEs, partially as a result of having a reduced surface area. All right, so now if we go to a multi-stage build, so now we are going to use Maven as a build step, and we're going to use our standard JRE as the runner of the application. So we're going to build first. There we go. So again, relatively quick. This was our multi-stage build. Everything looks fine. If we run this, oh, sorry. And again, if we look at the images, the first one in the Maven multi-stage, so that is already quite a bit smaller, obviously, because we've removed Maven from the image at the end. The next step in the demo is running the multi-stage with the Chainguard Maven image. And we'll see if we look at the output again. We've reduced the surface area a little bit, and we've gotten this down to 310 megabytes. So a little bit of a reduction, still good. And again, if we want to try and run this, oh, let me kill this 1 second. I've already got it running here. So I'm going to take the multi-stage application that we have. Again, very simple. Run it. Take a look at the output. And relatively straightforward. Hello world, I love Chainguard. All right, so demo's relatively straightforward. It's really just to demonstrate the lowered surface area of the images that we build as bases, and doing something very simple with a multi-stage build, showing the final output and looking at the final sizes. So all in all, in the end, going to the Chainguard multi-stage build, we go from the largest of being like 655 megabytes down to 310 megabytes. So generally, a fairly good result. I'm going to go back to the slides quickly here. And I'm just going to take a look in the Q&A just to see if there are any questions. All right, so someone has asked a question about adapting the Chainguard to the JRE FIPS image. Generally, it is not difficult. We have tried to align. So first of all, we use Bouncy Castle for creating our FIPS images. And we've tried to align everything from the build tools to the application images as well. So our Maven image, our Gradle image, they also work in FIPS form. So say you're generating a key store as part of your build, or doing an interactive build with Maven. The build tools work in FIPS mode, and generally we add the Bouncy Castle BC FIPS library and change all the security policies. We have one package that applies the FIPS mechanisms to the JRE and JDK, and then we apply this to all of the builds that we have. Are specific Java versions like 11, 17, 21 available for free? So the images that we make available are the latest and the EAs. So Java 24 EA and Java 23 are the versions that are free. Any version prior to that requires a subscription from Chainguard. And 3 new chats. So someone's asking about the 54-year-old Java image. So that is a build from Jib, which we're going to go over. And what Jib does to try and make the build idempotent is that it zeroes out the time entries. So in zip entries, it puts a time of 0 in there. So it goes back to like January 1st, 1970. And that's how it tries to produce. If you ran a Jib build and then a day later you ran a Jib build, the output would be the same because of the zeroed out time entries, and it would be byte for byte reproducible. So even in Maven or any of the build tools, if the time entries are not taken into consideration, that if you build something at 2 points in time, the checksum of the overall output is not going to be the same, and it would be very hard to tell that you had the same output. For the latest versions of the images, we remediate them and make them available as fast as fixes are available. So we do this generally, but for the latest versions of the JREs and the JDKs, we generally make fixes as soon as they are available and they are published. We do that for the subscription versions as well, but the process that we use for the images that we make available for free and that we make available via our subscription undergo the same security policies internally, and they're released as fast as possible. All right, I think that's all the questions answered. Yes, the same security remediation is made available for the free images as they are for the subscription-based images. All right, so back to the slides. All right, so you'll be able to see the results, but generally our images are smaller by quite a bit, and we have 0 CVEs, and that gets fixed and remediated on a daily basis with advisories published about what is being fixed on a daily basis as well. All right, so someone already noticed from the output, Jib is another fairly popular tool in the Java ecosystem. It's quite useful in that it does not require a Docker daemon to build the image. So if you're running build farms in Kubernetes clusters, it often is less of a hassle to try and get something running and working that doesn't require a Docker daemon. It is written in Java. It knows how to grab base images and layer Java applications on top of those base images. So if we take a quick look at, we're just going to take a quick look at the Maven POM. So I'm going to switch to the terminal again. And if we take a look at the POM that we have here, we'll see that there is configuration. Again, I have locked down with a SHA-256 the image that we're using in today's demo, but normally you could just put in an image reference for the latest or a normal tag. So you have the base image that you want to build from, and the name of the image along with the tag that you want to use for the output. So this is an image build done in pure Java. I've been using Jib for years. I generally use it over Docker myself for most of the projects that I work on. So building the image. And with Jib, you can write things to a local registry, or you can use the Docker daemon to make it available for local use. It's not required to build the image, but if you want to build it locally and work with it, it's easier than having a local registry that you're running. So same type, nothing is different. The CVE count is going to be the same. Running the Jib version of the image is going to yield the exact same result. It's just a Docker daemonless way to build an image. So again, as we all do, we love Chainguard. Okay, so back to the slides quickly. So again, no difference. The image built with Jib using Chainguard as a base image is has 0 CVEs, as we would expect. Let's see. I think there's, oh, I thought there was another question there. All right. So it often comes into play that you might want to inspect the image that you're working with. And because we have a reduced surface area, there are no shells, no other tools, and this can sometimes make debugging the images difficult. So there are dev variants of the JRE and JDK images if you need to shell into the image and take a look and see what's going on. So I will briefly show you how that works. So instead of using the normal base image that we have, we are going to use the tagging strategy that we have. So if you grab the latest JRE from Chainguard, if you use the tag latest-dev, you will get the dev version, which has a shell. So if we were to try and shell into the standard image that we built, we would we're going to try and shell into the multi-stage Spring Boot-based application that we built. So we're going to run Docker. We have an entry point of a shell. And as one might expect, it's going to fail because there's no shell in that image. If we build the dev-based version of the image, it's got a shell, it has some other tools. And we can see that we can actually shell into that image. Now, you may want to run some or install some other tools. You find you have a problem, you want to look at something. It is possible. If you run something like this, where you start up the shell using a different user, using the dev-based image, you can shell into the container. You might need something like another APK package. So you could do an APK add file, for example, and it will go grab other packages from Wolfie to install, whatever they may be. You might want to install some file utilities, curl. In this mode, you can run the Spring Boot application from inside the container if you need to debug it. So there's dev variants of almost all of the containers that we run that we build, and that they are also available for JREs and JDKs. All right, so where you might. Okay, great. All right. I'm just looking. So we have all the LTS versions. So we have 11, 17, 21. We have the latest, which is currently 23, and we also make the early access versions available. We just started doing that about a month ago. So if the latest version happens to be an LTS, then it is available. Otherwise, that is, again, something you would need a Chainguard subscription for. But we do have 8, 11, 17, 21. We do produce all of the LTS versions, and we build them as they are released on a quarterly basis in official form from the OpenJDK sources. And this is something that all OpenJDK providers do because the source code is released at the same time. So we follow similar programs to Temarin and Corretto, for example. All right. So we're not going to do full demos of like Docker debugs or using ephemeral containers and Kubernetes, but we are likely to have blog entries on those at some point in time. All right. All right, so we just actually did this. Great. Okay, so in summary there, trying to use Chainguard images is generally straightforward. It's generally easy to replace your existing Docker files or jib configurations with references to Chainguard images. We actively cut down all of the dependencies on a daily basis. Things are kept up to date on a daily basis. We provide patches to upstream. We hold on to patches if it's necessary. It's not something that we like to do by default. And we're issuing security advisories, and this cycle is happening constantly on a daily basis. Even if the JRE and JDK sources are only released on a quarterly basis via OpenJDK, other vulnerabilities on the base container are changing all of the time. So it is very common that we are rebuilding the JDKs and JREs many times a week, if not daily, to eliminate those security problems for the dependencies that a JRE or JDK relies on. It's a constant ongoing process. Right. So, yeah. In short, building all the images, try to be secure, constant process of improvement in fixing all of those things. And further resources that you may look at are the images directory. Of course, all our JDK and JRE images are available there, but also all of the other images that we provide. And we also have references to our Chainguard Academy, which has lots of just general container security, lots of information, really good lessons for any of your developers. And that is it for today. I'm just going to take a look to see if there's any other questions. Is it possible to create distro-less image using Chainguard? So you could yourself, but we are essentially making distro-less images already. If you wanted to try and use our base images and make distro-less images, some people do that with our base images that are available. But essentially, the images that we're building are equivalent to distro-less. So if you look at our Node image or Ruby image or Java images, they are effective equivalents of the distro-less images that Google provides. There is nothing on there but the application runtime, and you place your application on top of the application runtime, and it's the lowest surface area that you're going to get for running an application in production. All right. Great. That is it for me. Thank you for attending. I hope this was useful to you. And if you have any questions, please feel free to reach out.